All right, so here is that first problem. F of x equal to 2x minus 6 over x minus 1. So first thing you want to do is factor as much as possible to see if anything cancels. So all we could do is in that numerator, take out 2. So that didn't do anything, nothing canceled. So nothing canceled in this case. So if nothing canceled, that means you don't have any holes, or what I call restricted values. If you check out the other video, you'll see how you get restricted values, how that would play a role in you graph. And basically, you have a hole right there at that restricted value, whatever that order pair is. So, check it out. Let me know if you need me to make another video on it. But that would be where you would have a hole or a restricted value. Okay, but that's only if something cancels out when you do your factorization. You have x minus 1 over x minus 1, they cancel, something like that. All right, so for number 2, find the vertical asymptote. You set your denominator equal to 0 and solve it. So that's x minus 1. And add 1 to both sides, that gives us x equal to 1. So you have a horizontal line, x equal to 1, an invisible horizontal line at x equal to 1, where your graph will not cross. That's what these asymptotes represent. Horizontal asymptote, because our powers of x, highest power of x in the numerator is 1, highest power of x in the denominator is 1, they're both the same. So I will go ahead and operate this way. 2x over x is just 2 over 1. And so that's 2. So my horizontal asymptote is y equal to 2. And I think here I did like this. I meant vertical when I was doing my generic graph. Anyway, so vertical asymptote, vertical line at x equal to 1. And then here we're going to have a horizontal line, y equal to 2. And so I got x equal to 1, y equal to 2. Let me see if I did my stuff right down here. 1, 2. Okay, that was cool. I was just making sure. All right. So, and also notice your vertical asymptote is x equals. Horizontal asymptote is y equals. So always make sure you're careful with that. So then looking at our y-intercept, you're going to let x be equal to 0 and then solve for y. Don't forget f of x represents y. So I just went ahead and replaced it. Y is equal to 2x minus 6 over x minus 1. So I plug in 0 for x. Solve, that gives me negative 6 over negative 1, which is just 6. So my ordered pair is 0, 6, because x first and then y. And then I have my x-intercept. We let y be equal to 0 and solve. That's what I did here. What you have to do is multiply both sides by x minus 1 so that they can cancel down here. And then x minus 1 times 0, of course, is 0. So we have 2x minus 6 equal to 0. Add 6 to both sides, divide by 2. X is equal to 3. So we have a vertical. We have a x-intercept at 3, 0. X-intercept. So this is my x-intercept, 3, 0. Y-intercept is 0, 6. All right, now the plus or minus test, wasn't sure exactly which one they wanted, so I did this one. Let me know if you saw something different or something else that they wanted. So you set the numerator and the denominator equal to 0 and solve to set up our intervals. So that's what I did here, 2x minus 6 equal to 0. X minus 1 equal to 0, solve for x. I got 3 and I got 1. So when I go to the generic number line, I have these intervals of negative infinity to 1, 1 to 3, and then 3 to infinity. All right. So then you pick test values in those intervals. So this first one's anything less than 1. I chose 0. Here, anything in between 1 and 3, I chose 2. Here, anything greater than 3, I chose 4. So what this is doing is it testing the behavior of the graph, letting us know where I would have positive values versus negative values. So when I plug these test values into my equation, my function, my graph behaves positively here, negatively here, and then positively here. It doesn't matter necessarily what the number is. We want to know what sign are we getting. So that's what I did here. Plug in 0. Negative 6 over negative 1 is going to be a positive 6. I didn't write positive 6 right here because it really wasn't about getting a positive 6. It was like, did I get a positive number? And I'll show you how that helps, helps us to know where the graph is in a second. Do this work, plugging in that positive 2, I end up getting a negative number. And if I plug in something greater than 3, like 4, I would end up getting a positive number. So this is the behavior of my graph. So from 1 to negative infinity, I will have positive numbers. From 1 to 3, I will have negative numbers. And then for 3 to infinity, I will have positive numbers. All right. So this is what I got. So my vertical asymptote is right here, x equal to 1. That's why I have a vertical line right there. Imaginary, I did little dots, the imaginary vertical line. Y equal to 2 is right here. So it's my horizontal line, imaginary line there. And so my graph will never cross. My graph will never cross those imaginary lines right here. These red lines, the graph will never cross it. Now, I have intervals from negative infinity to 1. 1 is right here. Then 1 to 3. 1 to 3 is from here to here. And then 3 to infinity. So now from negative infinity to 1, that's from here to here, everything is positive. And you see that this line is above the x-axis. So that means everything's positive. So if this is my graph, or then I have these asymptotes, all I could do is write it that way. All I could do is curve up according to those asymptotes. And then when you're talking about from 1 to 3, I have negative values. So all it can do is respond this way. Notice how it curves down. And then up to the horizontal line. And then from, let me see if I can erase this. Let me do this. All right. And then from 3 to infinity, I have positive values. And that's why this purple line is above the x-axis. So being positive and negative lets you know if your graph is above the x-axis versus below the x-axis. Positive means above x-axis. Negative means below x-axis. All right. And so, and then also it told you to use Desmos. I had Desmos up. Hold on, let me pull it back up. All right, so using Desmos just confirms all of our points and how it's supposed to behave. So even if you wasn't as clear as you would like to be on the positive negative piece, it tells you, the thing told you to use Desmos. So Desmos will help confirm, all of your points. Asymptote see how there's an imaginary line that this graph will never cross, and one right here as well. And so that will help you to graph it. So, just on how to use Desmos, make sure if you do 2x minus 6, and if you were to do divide, notice how I set it under the 6. But really, if you want to put it that 2x minus 6 in the numerator, the whole 2x minus 6, then you have to use parentheses. Now when you hit divide, it puts the whole 2x minus 6 in your numerator. And then the same thing with what is x minus 1. If I do x minus 1, just got to make sure it's all the way down into your denominator. And then there go our graph. And you see right here, have an intercept of 0, 6. That's your y-intercept. Here, this is your x-intercept. All right. So try it out. Let me know if you have any more questions, if I need to make another video or not. And I'll talk to you soon.